Okay, in this video we're going to go ahead and take a look at solving trigonometric equations here. And it's really just going to be the infancy of these things because we're going to introduce ourselves to the inverse trigonometric functions here. So to do so, what we're going to take a look at is just, we're going to start off with this part up here before we start looking at this diagram down below, and then we're going to run through some other graphs that were generated on Desmos to see why all of these things are what they are and how to use them. So let's start off with this part right here, okay? And so what we're looking at is the following, okay? The first thing that we have is something called arc sine, okay? And it can also be written as this right here, like an inverse function, the inverse sine. And that is going to always equal an angle. And so, for example, if I were to, in this particular case, say something of this sort. Let's take a look at this triangle right here, okay? Is that if I wanted to know this angle here, I can say the following. The arc sine of, and if we look, this is going to be 5 opposite over hypotenuse for sine, and so the arc sine of 5 over 13, or the inverse sine of 5 over 13 is going to go ahead and give me, and we're going to need a calculator for this particular example. So let me cue that up. Okay, and this is in degrees. So this is going to yield at the end of the day 22 point, and I'm just going to go out to 2 decimal places, 62 degrees. Okay, and so let's go ahead and take a look at how this is different than sine. Okay, just regular sine. So sine, if we dropped in 30 degrees, now notice we're dropping in a degree, okay, or we're dropping in an angle, and we're getting out, sine of 30 degrees is 1/2. We're getting out a ratio. And so, since these are inverses, our inputs and outputs, our input for a regular sine is a degree. Our output is a ratio. So those are going to switch for all of these guys right here. We're going to drop it in a ratio, and it's going to fetch us a degree. And that's pretty powerful, considering some of these degrees, like 5 over 13, have a very peculiar answer or degree measure for them, okay? So what I want to do is I'm going to back this up a little bit, so I'm going to erase that part out, and I'm going to set up arc cosine and arc tangent and show you how it will all go ahead and yield the same result. So let me set that up. Okay, so I have the arc cosine and the arc tangent all set up there, and it looks like when I put them into the calculator, and to show how they got set up, okay, is that I have the cosine, which is going to be 12 over 13, adjacent over hypotenuse, okay, and then I have tangent, opposite over adjacent, that's where the 5 over 12 comes from, and they're all going to equal the same thing. And so basically that means is that these things, when I go ahead and basically tell them, you know, to put it in words, any of those, is that, for example, let's just do the sine example. It says, fetch me an angle whose sine is 5 over 13, and the answer is 22.62 degrees. Same with cosine, same with tangent, okay? And so that's the way that we start off understanding where or how these things work. Now, we're going to need some background information for this part below, and we're going to take a look at some graphs and see, putting all these things together to understand why these graphs are what they are. So let's go ahead and take a look at that graphical approach in the next video.